Okay, so in today's exercise, we want to do some communication between our host computer and the NetBurner board over the network link, over the Ethernet cable, using the sockets API. So I provided some simple client and server code to get you started. So you want to download this, and this is the source code for the host computer. So on the course website, go to the lectures link, and then for the exercise download, it's called tcbcom.zip, and then extract the files out of the zip file. Now, I'm going to use our MSys 2 routine that we were using for um, that we were using for RTEMS to actually build these routines. They should build under MSys easily, or Cygwin, um, um, or under Linux. But once you extract the routines, you should have these, 5 files: simple client, simple server, simple utilities, and simple utils.h. So navigate to that directory from your MSys command window, and then just type make to actually build the code. Okay, and this should build actually 2 routines, a server routine and a client routine. Let's take a look at those. So here's actually the client routine first, and this is a little bit more complicated than the corresponding client routine will look on the NetBurner. The basics are here, but actually it's a little bit simpler on the NetBurner than it is under Windows. Is actually a little more complicated than even Linux to do sockets programming. But kind of the basics are here. Now this program will not run on the NetBurner. For one thing, it uses the standard C++ library. So I've got streams here, so it'll run fine on your Windows desktop. But if you'll notice, on the client side, the first thing we do is connect. Now here we actually building up the server address, which is actually passed in via command line argument, is again a lot more complicated than the corresponding connect routine on the NetBurner. So refer to the NetBurner documentation, but the basics are here for a client. We connect, and then this actually displays some output to standard output, and then enters a loop. And then in this case, our client prompts from standard input. It prompts the user for a string, okay, and then that string is just sent across our socket that we actually get from our connect routine. Is sent across the network, and then we immediately read it right back. Here I'm using receive V because that's what Windows uses instead of read and write, but on the NetBurner you would actually send write and read would be the corresponding routines on the NetBurner. And then we read the response. The simple server in this case actually just converts the string to uppercase and sends it back on the server. And then this just loops until the user types in a single period for a line, and then that actually then closes the connection and then exit the client, and then doesn't close down the server. We could then run the client. The server code, again, the basics are here. Again, it's more complicated on Windows than it is on the NetBurner, and Windows we have to actually create a socket, and then we have to bind to it. You don't have to bind on the NetBurner. You actually just start listening on a particular IP address, and then that returns a listening socket, and then but then the rest of it is similar. In a while loop, we accept a connection on that listening socket, and then communicate with that client. This particular server can only handle one client at a time. So again, we'll expand on this next time and build it to actually handle multiple clients. So here we just read from a response from the server, and then what we do is convert it to uppercase and then send it back. And then this will exit out of this loop if we get 0 back, and then that's when we close down the socket. But then the server goes back and then reads actually another waits for another client connection. We can just shut down the server with Control C. There is a special string that if you send XXX across the connection, then that actually causes the server to shut down as well. So so we've made I've run make here to actually build the simple server. So let me run the simple server in one window here. Okay, it's actually listening on port 10,000 that was hardwired into the code. So in another routine from the same directory, I want to run the simple client. And the simple client routine takes two arguments. It takes the IP address. I'm going to use first what's called the loopback address, and this should work on your own machine, 127.0.0.1. It means connect to this machine. It's every machine uses the same IP address, and then I have to specify the port number. Okay, and then so you'll see the server responded in the other window that a client is connected, and then now I can just send strings across. Hello there, sent across to the server, and then the server actually responds with hello there, and then the client prints that to standard output. Okay, and we can continue this. A single dot causes the client to close the connection. On the server side, we see the client has disconnected, and then I can reestablish this connection. I'll show you here what happens if we try to connect two clients simultaneously. I have to get over to that directory, which is buried deep in my directory tree. So if I try again, simple client 127.0.0.1, 10,000. Okay. It says it's connected, but I don't think we'll get any response. We won't because our server can actually only handle one client at a time. It's actually in the listen queue right now. The server is only communicating with this client. But if I disconnect this client, you'll see that it immediately accepted the other client and then actually read the response from that client. Okay. Again, I can, if I send XXX across, it'll cause the server to close down and causes the client to close down as well. So again, that you wouldn't have to do that. I could just hit Control C on the server. I guess the other thing I'll illustrate here. Let me start up the server again. Is let me get the actual IP address for this machine. It's 192.168.113. I can also connect, instead of using the local host, I can use the actual IP address for this machine. 10,000, and connect via that IP address as well. And then close down the connection, and then this time I'll just use Control C in the other window to actually shut down the server. In the rest of this exercise. Okay, so we've kind of walked through this, and I encourage you to do this on your own machine. You can, if you've got maybe a laptop and a desktop in your dorm or on the same network, you should be able to actually run the simple server on one and the simple client on the other. I suggest here, if we were in the classroom, we could have students running on clients and servers on different rooms in the classrooms. It says here I've got the program running on CS Server. I don't. You could, if you wanted to, transfer the software over to CS Server and build it and run the server there and try the connection there. Um, the port is actually blocked. So I don't think you can connect externally. Even if you started on CS Server, you could secure shell over. So, and the rest of this, and the first step is to write a simple server on the net burner that is compatible with the simple client. So I don't suggest you start from the simple server code. Use that as a guide to build your simple server on the net burner. The socket API is different enough. Again, it's a lot simpler on the net burner. You will have to just listen and accept. There's some good documentation in the NetBurner Network Programmer's Guide for the NetBurner, and so use that information to build the client on the NetBurner, and then run it on the NetBurner, and then run your simple client on your host computer. You'll have to pass the IP address of the NetBurner. I forget what we set that to, but whatever we set that to, and then have it listen on port 10,000, and then reverse that. Again, you don't have to write any new code on your host computer, but you do have to write this code on the NetBurner. Now write client software on the NetBurner that connects to your host machine. Again, using whatever IP address that has. And you can it says here, when the simple client starts, prompt the user for the IP address and the port number. That will be over the serial port connection. You could alternately hard code that into the client. And then your client should actually prompt over the serial port for input, and then pass that across the network connection back to the host, and then display that. And then the next step, if you get both of those, is write an application on a NetBurner that runs the simple server in one task and then the simple client in another task. So both these would then be running on the NetBurner, but the simple client would accept input from the serial port, send it to the server, which uppercases it and sends it back, and then the client should display the output over the serial connection. But in this case, both the client and server are running on the NetBurner. And then in the final, most elaborate case, write a server on the NetBurner that can handle up to 4 simultaneous clients by actually creating a new client task every time a client connects. So this is one way to handle multiple clients is actually through multitasking. You have to pass. Every client has a different socket file descriptor, so you have to pass that socket file descriptor to the server, the new server task that handles each client. So give these a try. It's a little more involved than our typical exercise. I'll post solutions to these on Thursday, but I want to give you a little time to work on these. Again, our next project is Thursday. I will assign our last project on Thursday. We've kind of run out of time this semester for actually to have you do a final project. So I'm going to scrap that and give you one final networking project on Thursday that will actually wrap up the semester for us. At this point, I plan to actually post the final lecture on Thursday, and then that will give you, a week and a half to actually finish your final networking project. I will be available if there are any questions on this last project. But give this a try. And on Thursday at 9:30, we will have a Zoom meeting, brief Zoom meeting, so I can try to answer any questions about the course. But that is it for today.